get this done. All I'm going to really do is just go through where this is located. So the first one, pi over 6. So if this is their 0, this should be 6 pi over 6. Should be. This should be doubled, 12 pi over 6. 6 goes into 180 how many times? 30. So it's a 30-degree triangle. So where do I find, what quadrant do I find 7 pi over 6? Third. Because this is 6, one more is 7. Remember, I make a bow tie. Here's my bow tie, one above. I wear this big red bow tie. I just make one above and one below. So if this is 6, this would be 5, this would be 7. If this is 0, this is plain old pi over 6. This is 1 before 12, this is 11 pi over 6. So again, it has a 30 degree. So on the unit circle, since we did the unit circle, if you did 1, 2, radical 3, you're going to divide everybody by 2. So this is going to be 1/2, radical 3 over 2, 1. And in this quadrant, both of these guys are negative. And your radius always positive. From this, can you make your sine, your cosines, your tangents okay? Is anybody struggling with sines, cosines, tangents, reciprocals? Don't rationalize. By not rationalizing, all you have to do for your reciprocals are literally take the reciprocal, flip them over. If you rationalize, then you're going to have to either unrationalize or re-rationalize. So keep it simple. Where do I find pi? At the 180, right here. So this is my unit circle. Remember, x, y, cosine, sine. So what's the cosine of pi? What's the sine of pi? What's the tangent of pi? 0. It's y over x. I take my y over my x, and this gives me 0. Okay, we're good with these? Stop me if you have any questions. I should have reset this thing because this is weird today. I'll go away and my board misbehaves. All right, what quadrant do I find 3 pi over 4? Second quadrant. So I say pi over 4. This is 0. How do I label this one in terms of over 4? I want the same one. Good, because I want it to cancel out the pi. Again, I wear a big bow tie. So 1 before 4, there's my 3 pi over 4. This angle right here. It starts here and it terminates here. 4 goes into 180 how many times? 45. That's my reference angle. So I label. And if I label these 1, 1, let's do this. 1, 1, radical 2. I'm on a unit circle. I'm going to divide everybody by radical 2. So 1 over radical 2, 1 over radical 2, 1. X is negative, y is positive, and radius always positive. We go with finding all the parts to this. X is the cosine, y is the sine on a unit circle. Okay, negative 5 pi over 6. I start the same way. This is my 0, this is my 6 pi over 6, this is my 12 pi over 6. How many times does 6 go into 180? 30. So I have a 30-degree triangle. What quadrant would this be in? It's a negative rotation, so it's coming clockwise. Third. I'm coming this way. I'm going to stop short of 6. There's my 5 pi. It looks like the same count, just go the opposite direction. How many times does this go in? 30. So now I know this is 1/2. This is radical 3 over 2. This is 1. x and the y, both negative. Do you find that this helps an information box? I always label my triangles with positive values only because if you put like negatives, they tend to get lost. Mine do, because I write so badly. But also, I find that those are distances. So if I'm going to put my point out here, God bless you, then I do make it with a negative, God bless you. But I usually put it in my information box, and then I don't forget about it. 5 pi over 3. How many times does 3 go into 180? 60. So, if this is 3 pi over 3, and this is 6 pi over 3, what quadrant am I in? 4. I come all the way around, and I stop 1 before the 6. This is where I terminate, right here. This is my 60-degree reference angle. So I say radical 3 over 2, 1/2, 1. And radius always positive. Good with these guys, and everybody can do the rest? All right. And the last one, I just had you do the same thing almost, but come the opposite direction. 3 pi over 3, 6 pi over 3. Going the opposite direction, I'm going clockwise. What quadrant is negative 5 pi over 3? 1. I come all the way around, and I stop before the 6 pi over 3. I'm in quadrant 1. And again, you're going to have the same values. But everything in quadrant 1 is always positive. It's the same triangle, right? That you just rotate around the circle, or reflect, if you will. Now everybody do these. The angle is 60, because 3 goes into 180 60 times. You look over, there I just kind of outlined them for you. The ones that I want you to pay attention to are these guys. Oh my goodness, this is going to drive me crazy. We'll talk about those. We talked about coterminals last time, but these are the ones I want you to pay attention to. You know your cosine, you know those. When we do these identities, and you might remember doing this from last year, your tangent is the y over x. Your cotangent is its reciprocal, x over y. So sometimes you're forced to use your sine and your cosine, which corresponds to your x and y. Pythagorean identities, do you remember doing these?
We did them like 2 days before the regions.
Okay, so very easy. This is this is how you remember your Pythagorean identities. You don't have to memorize anything. So you come over in your circle. Here's your circle, unit circle. So my radius is 1. So along the x-axis measures my x. True, right? Along the y, parallel to the y, measures my y. What's Pythagorean's theorem? A squared plus b squared equals c squared. So if I put x and y, what would it be?
C squared.
Equals 1. C squared, which is 1 squared, right? So is that true about Pythagorean's theorem? X squared plus y squared equals c squared. Remember, c is 1. So isn't it this? So on a unit circle, is the x the cosine or the sine? So I can replace this with cosine squared. I can replace this with sine squared. That's why it's called the Pythagorean identity. It's x squared plus y squared equals 1. You don't have to memorize anything. You guys already know a squared plus b squared equals c squared. Basic triangle, x, y, 1. Now, oops.
What is that thing you're writing after this?
This is a theta sign. Something's wrong with my board here today. This is a theta sign. Now, how do I get to the rest? Okay, I've got the words cosines and sines. I'm going to divide everybody by cosine squared. Everybody by cosine squared. So what's cosine squared over cosine squared? 1. What's sine squared over cosine squared? Which sine over cosine? Tan. Tangent squared. And what's 1 over cosine? Secant squared. There you go. Isn't that the other one? There's your other identity. Isn't that the second one? Easy, isn't it? Now, the last one, divide everybody by sine squared. You only have 2 things you can divide by. You can't divide by 1. It's the same thing. You get the same exact thing. So you either can divide by a cosine squared or a sine squared. So what's sine divided by sine? 1. Oops, sorry. 1. What's cosine divided by sine? Cotangent. And 1 divided by sine? Cosecant. There's your Pythagorean identities. Don't memorize it. Drop a triangle with a radius of 1 on your unit circle and figure it out. I'm not big into memorizing, except for you have to memorize your 2 basic triangles. Questions on this? Take a little time to digest it.
Do you know what to divide by?
Well, you only have 2 words in there, sine and cosine. You can't divide by 1, because dividing by 1, everybody would be the same, right? So 1 time around, divide by sine, and you get sine over sine. That's the 1. Next time around, divide by cosine, and you get cosine over sine. Cosine, that's the 1. So there's only 2 things you can divide that by.
I just wondered why I don't support. Because like the end of last year, Mr. DiCaprio said he doesn't support the trig regions, so how they didn't teach us trig in Common Core. And he said, here's some packets I'm not teaching you. Great teachers. That's what.
But that second time around, it should start making a little bit more sense. And I love trig, so I'm going to show you everything possible to make you like it. All right. Now, how do I know, Chris, since you're so talkative today, that point 12 negative 5 is not on a unit circle? How do I know the point 12 negative 5 is not on it? It says this is a non-unit circle. How do I know it's not a unit circle? Why can't I make this be a unit circle? That's a very good question. What's your radius on a unit circle? 1. Okay. Does that help? It can't what? It still can be a negative. I can have negative number there. What quadrant is that? Is that point in? 4th, in the 4th quadrant. Because 12 is more than 1, so it can't possibly be a unit circle. Thank you, Lily. It can't possibly be a unit circle because if the biggest side of your triangle is your radius, could your x value be bigger than 1?
No.
So this is a non-unit circle. But I come around. You guys told me this point I could find down here somewhere. 12 negative 5. It's going to be on my circle. So my angle is going to come here, and it's going to terminate at that point. And I'm going to drop a triangle. It's not necessarily going to be a special right triangle. It could be, but it doesn't necessarily have to be. It could be a triple, those special little triples that you had. So now, I need to know how to set this up. This is my x, this is my y. My x is 12, my y is negative 5. I don't know my r. I don't know my radius. It's not 1. How do I find my radius? There you go. There's the Pythagorean identity. So you're going to get 144 plus 25. And r is 13. And remember, radius is always positive. Nope. You're on a non-unit circle. You could, but it doesn't make any sense to do that because when you do this, all you're going to do is write from here, say the sine of this angle, y over r, negative 5 over 13. So you don't have to take that step. You'll do it right here. Cosine of an angle, x over r, x 12 over 13. Tangent of an angle, y over x, negative 5 over 12. Can you find your reciprocals okay just by flipping those over? Okay. Always reduce to lowest terms if you can. And a trick to this is if this is your, just for instance, I don't know if this works out, whatever this happens to be, I don't know, I'm just throwing numbers at you. If you find your information box here and you say, well, they're all multiples of 2, divide everybody by 2 right here so that you don't have to take your ratios and then divide them. Just divide them by 2 up here and then they're all reduced. Yes?
So you only don't have to put sine and cosine over 1. You can only put it
Over 1 when it's a unit circle. On a unit circle, your x value is your cosine because it's over. We still do y over r, x over r, but on a unit circle, when this is 1, so if we say x over r, so your x, say, is like 1/2. So if we say this, it's 1/2 over 1, so we really don't need to put the 1. That's why on a unit circle, the x value is exactly the cosine, but not on a non-unit circle. All right. So if I gave you this, you could find me the missing part. Which part's missing? The radius or the hypotenuse? You could find me all the pieces, right? This guy right here, these are just all positives right now. These are just triangles, they're all positives. I don't have anything on my triangle. So on my triangle, if you want to go by SOHCAHTOA, because it's not on an axis, cosine is adjacent over hypotenuse. This is your reference angle. Hypotenuse is always opposite the right angle. My adjacent to me is 5. Can you guys figure out the other piece? Okay. Everybody okay with that part? So they're just positives because it's like we're heading towards an application. So if I took it off the circle, it just gives you a basic triangle. Okay. I'm looking for an angle in quadrant 1. So I'm dropping my triangle in quadrant 1, and I know one thing. Its tangent is radical 3. I gotta find the rest of this. So what is tangent? What letters? Y over x. So I label my y radical 3. I label my x 1. Does that look familiar to you? What's the radius? 2. What angle is this down here? What reference angle? 60. So my angle is 60 degrees. In radians, what's my angle in radians? How many times does 60 go into 180? Pi over 3. Okay. Good. Find me what quadrant this angle lies if my cosine is positive. Hang on 1 second. My cosine is my x value. My cosine is positive wherever x is positive. My tangent is negative here and here. Where do they overlap? That's where my angle is. We'll spend a little bit more time with that one, but you should be able to get through all the homework, okay?